Okay, so having sat through some of today, this is going to be a very different speech. Yeah? And I'm the only thing between you and dinner as well, so this may or may not work. To give you an idea of my background, I did actually start programming in 1972 when the headmaster, yes, I had the sense to stop a few decades later, right? This was when the headmaster gave us punch card machines and told us we'd have a job for life if we learned how to use them. Teaching people Java code in school is probably the modern day equivalent, right? By the time you get to university, everything has changed. Yeah? My degree at university was physics and philosophy, and you'll see some of that come through in a minute. And I also specialized in aesthetics, the philosophy of art, so I'm going to pick up on some of the last speaker stuff in a minute. Right? And then after a period working in, effectively in human rights work in Australia and Latin America, I had to get a job, and if you're young with a degree in theoretical physics and philosophy and 3 years of swanning around the world doing social good, you're virtually unemployable. So I ended up in HR and training, because they'll take anybody if they're cheap and have got international experience. And this was actually when computing was really starting to take off in business, so I then self-taught myself and actually built HR systems, pension systems, and then moved in effectively to be financial director and installed a whole bunch of computer systems. So that was kind of like, from my point of view, this is the early days of computing, where we saw it as a novel tool rather than a career. And I'll come back to that point in the end, because my generation still see it like that in terms of the way we work. And then later on, I worked on 4GLs and 5GLs, and particularly working on decision support systems for companies like Guinness Group worldwide. And that was actually quite an interesting period, because I had been a financial director, I knew what the application was, but I could pick up a 4GL fast enough to actually write systems without the need for user requirements. In fact, if you asked the users what they wanted, they had no idea what the technology could do, and therefore it was a mistake to involve that sort of definition, because you'd end up with something inadequate. In fact, there's a general thing at that point, and you can see this in a lot of IT, that part of the problem with users is when you deliver something you can prove they asked for, it turns out they want something else instead. And that's been very common for several decades. And that links in with the main theme of what I'm going to talk about after I've built some theory, which is how we actually manage unarticulated needs. Because at the moment, the pace of change in technology is faster than users know what to ask for. Yeah, therefore, anything a user asks for is almost by definition out of date. And to some extent, I want to rebalance the famous snowbird agile stuff and saying they swung the pendulum too far. They went from we know best to they know best, and actually, dependent on the context, it will be somewhere between the two. And that will link in with the work we've been doing for the last year with people like Stanford and Rand Corporation and others on a complex systems approach to design thinking. So I'm going to introduce some of the ideas from that as well, because they relate to work we plan to start this year on a complex adaptive systems approach to software architecture. Because at the moment, architecture is one of the great issues in terms of large-scale system design. I'll be prepared to defend that later. So I'm going to start off by giving you some of the background to this. This slide here kind of like makes the point for me. Oh, don't you? Yes, you do. Still haven't changed it. I left that up for the start. I like this slide. This is from Gaping Void, who we work with a lot. When we're doing, for example, things like mapping cultures, we actually start off by giving people a series of his cartoons. They choose the one which most represents their culture, and then they interpret that cartoon. That's actually much more effective than a questionnaire. Abstractions art gives us ways to say and understand things that you can't get through raw text. So that's kind of like one of the cartoons. But what we've had for the past 20 or 30 years with the dominance of systems thinking in management science has effectively been an emphasis on automation. I, for my various sins, got to talk leadership with Peter Drucker in executive seminars for a couple of years before he died. And just to say something controversial, one of the things we both agreed on is that scientific management had more in common with complexity thinking than either had with systems thinking. And the reason is, if you go back to scientific management before the 1980s, management was still an apprentice-based task. You still joined a company, you learnt your job, you got promoted. By the time you were the CEO, you actually knew something about the organization. In the systems thinking era, you do an MBA at business school without any real experience. You join a large consultancy firm, and 10 years later, you're put in charge of an organization, and you only know how to manage through spreadsheets and formal reports. You don't actually have any of the tacit knowledge involved in it. Another example of that, if I go into a hospital in Britain, the head of the hospital is nearly always dressed in a suit, surrounded by assistants. If I go into a hospital in the States, the head of the hospital comes in from a ward in a white coat because he or she is still a practicing doctor. And they're therefore able to make judgments that the professional executive can't, and they have actual less wasted cost in terms of administration. I mean, obviously, the insurance market makes it really stupid, but at an administrative level, it's different. So the work I've been doing for some time, and this comes from the physics and philosophy, is generally held under the title naturalizing sense-making. Those of you who are philosophical in background will recognize the word naturalizing. It means to root what you're doing in a natural science. I've had intense dislike of management science for some time, and it builds on social science. If you do theoretical physics and philosophy, you get a contempt for social science from two completely different disciplines. Yeah, from a physicist's point of view, no social scientist ever has enough data to form any conclusion whatsoever. And from a philosophical point of view, social scientists are people who just didn't have the intellectual MIPS to manage the complex abstractions of philosophy. The other problem is that they constantly confuse correlation with causation. You know this way works. Somebody goes and studies 8 or 9 companies, 8 or 9 organizations, 8 or 9 programming teams, who they say do well. And let's leave to the side that, how do you know somebody's done well over the time period, but let's accept that. They identify things that they do, and then they say, if you do these things, you too will be successful. Everybody reasonably familiar with this? I say in real science, that's called the confusion of correlation with causation. So, for example, if Finland wants to increase the number of Nobel Prizes, all it has to do is increase dark chocolate consumption. This is good news. If you don't know it, dark chocolate consumption per head of population directly correlates with Nobel Prizes per head of population for the last 3 decades. That's better evidence than most social scientists ever had, so I strongly recommend you go out and consume. The other one I like, which I can see a causal link, is that drownings by suicide, the peaks in drowning by suicides correlate with Nicolas Cage movie releases. But again, as I say, I think that one is probably a causal link. I can understand that one. So the correlation causation thing is a massive issue, and management science is worse, and the agile community is even worse. There are 2 disastrous books which a lot of people talk about. One is Lean Startup, and the other is Reinventing the Organization. Anybody read them? Anybody love them? Because I'm about to actually antagonize you, right? Lean Startup, the guy goes and studies a bunch of his friends who created successful companies in Silicon Valley. Great news. And from that, he derives a set of things that they did and says, go do these, you will be successful. What he didn't do is study the companies who failed. When I was in the IBM research group, we actually did that with Dorothy Leonard at Harvard, and we found all the people who failed in Silicon Valley did the same things as the people who succeeded. Yeah, this is kind of like a little embarrassing fact. The point is, you've got a market, it's so big, some people are bound to succeed. Yeah, and implying some sort of causal link is a basic mistake. And it ignores the huge literature on what's called entrepreneurship, from Mack and others at Wharton College, which actually says, how do you create entrepreneurial behavior in a large company where you can't afford the level of failure that a market can afford? So that's one example. The other one is Le Croc's book, which talks about, I think it's jade, is it, or turquoise? You get very confused about spiral dynamics. They constantly invent new colors, which are associated with higher states of enlightenment, so they don't have to justify what they say because you're not at their level, right? The jade one is the latest one, and this guy's even worse. He actually goes and selects aspects of cases which support the proposition he wants to say, and he doesn't even report when it's actually very partial. For example, Zappos only managed to implement their particular holacracy technique by laying off significant numbers of their staff who basically said, we can't cope with this sort of approach. And interestingly, every of these so-called self-organizing communities was based on a draconian manager imposing something regardless of what his or her employees thought. Yeah, but again, it's very selective material. Now, this is a problem because actually all human systems are complex, and therefore we take a different approach. We say, what does natural science say about systems and cognition? And we develop methods and tools consistent with that. Because in natural science, they have this quaint idea that other people should be able to replicate your experiments. Yeah, again, something you don't see in management science in that sense. Oh, and by the way, most of the classic experiments in psychology, now people are starting to repeat them, they're not getting repetition. So be very careful what you pay attention to if it's based on observations of cases or controlled experiments. I have a visiting chair in the psychology department. I'm allowed to do whatever I like with the students. Yeah, in terms of experiments, they sign up to it first. So most of the experimental psychology work is based on psychology students who already know the field. Yeah, that itself is a problem. So the other word for this is also anthro-complexity. For anybody familiar with complexity science, a lot of it is associated with Santa Fe. That we call computational complexity, that's agent-based simulation. Anthro-complexity is this very simple proposition which says human beings aren't ants. It amazes me I have to argue this with people, all right? It seems to me fairly self-evident. The trouble is the modelers, their models only work if they assume that human beings are ants and they're making decisions based on rules responding to 64 different pheromone traces, which is actually how ants do it, right? The reality is in human beings we have the three I's, we have intelligence, we have intentionality, and we have identity. And those radically change and radically complicate any concept of model. Just as correlation doesn't equal causation, neither does simulation indicate prediction. Yeah, and those are two sort of important statements. So what I'm going to do is to quickly run through three aspects of the science and then talk more generally about some of the implications. So first, and this is kind of like the really scary one, this is looking at radiologists. Radiologists, on average, have 15 to 20 years of experience. They have a body of knowledge which is 3 or 4 generations old. IT is only 2 generations old, and that's problematic, by the way. As generations of knowledge build up, a lot of knowledge gets cemented into work processes. Young disciplines have problems. Older disciplines are better, but radiology isn't bad. So you basically give a whole bunch of radiologists a set of X-rays, and you ask them to look for anomalies. And then the final X-ray, you put a picture of a gorilla, which is 48 times the size of a cancer nodule. 83% of radiologists on average don't see it, even though their eyes physically scan it. Yeah? And the 17% who do see it come to believe they were wrong when they talk with the 83% who did. This is called inattentional blindness. We do not see what we do not expect to see. And in evolutionary terms, you can see why it makes sense. The most anybody in this room will scan of the available data before you make a decision is about 5%. That's on a good day if you're really focused. If you're Chinese, by the way, it goes to 10%. There are actually different evolutionary processes in the brain as a result of symbolic as opposed to non-symbolic language. But for everyone in this room, it's 5%. You then make a decision based on a first fit pattern match, privilege on your most recent experiences. It's a thing called conceptual blending. Yeah, you actually scan 5% of the data. That causes this trigger of memories of your own experience, things that you were taught, things you've heard from other people in narrative form. You blend that together and you come up with a unique form of action. That's how you all make decisions, unless you're fully autistic. The only people who make rational decisions by assessing all available data are autistic, which is why they can't operate. And if you think about it in evolutionary terms, you can see why this happens. If you imagine the first hominoids on the savannas of Africa, something large and yellow with very sharp teeth runs towards you at high speed. Do you want to autistically scan all available data, look up a catalogue of the flora and fauna of the African veldt, and having identified lion, look up best practice case studies on how to avoid lions? By the time you do that, the only book of any use to you will be the book of Jonah from the Old Testament, which is the only example I've found of how to escape from the digestive tract of a large carnivore, written by a purported survivor. We evolved to make decisions very quickly based on a partial data scan, privilege, and our most recent experiences. Oh, and by the way, in modern cognitive science, we don't call these biases, we call them heuristics. Evolution doesn't produce things which have no utility. So-called biases are actually heuristics that allow us to make decisions faster. But remember, we evolved to make decisions as clans and tribes, not as individuals. And that's one of the massive problems with leadership theory and decision theory in the West. We focus on the individual, we don't focus on the collective. Yeah, at an individual level, these sort of things are problematic. So that's one thing. Good news is there's a lot out there waiting to be discovered. If you can find the 17% before they talk to the 83%, you can do something novel. And I'll talk about how we're doing this in terms of design and how we're doing this in terms of unarticulated need later. The second one is something called exaptation. We had a significant problem with creationists for many years. I still do. I spend a lot of time in the States. I'm not allowed to talk about evolution with the Ebola management teams in the States because it's considered a controversial theory. This is actually quite terrifying if you think about it, right? Particularly being as Ebola is now moving from parasite to symbiote, which means it's learning to allow some people to survive, right? Either way, we had a problem because there wasn't enough time for human intelligence to evolve in a linear way. The sort of Richard Dawkins type approach to genetics, yeah, there just isn't enough time for human intelligence. And then Gould, Olding, Smee, and others discovered something significant. It's links with punctuated equilibrium. That basically, and I'll take dinosaurs as the best example, dinosaurs evolved feathers. We now know that all dinosaurs had feathers. If your children have books which say otherwise, they need to catch up, all right? This is good knowledge for you, all right? It gives you one up on children. This is coming out of the northern China discoveries. Not only that, the feathers were very colorful. And the paleontological evidence basically says feathers evolved in dinosaurs for sexual display. And the dinosaurs, one species of dinosaurs, started to develop skin flaps on their forelimbs. The skin flaps allowed them to better display feathers. Those are the dinosaurs that, when they fell off cliffs, glided. And that's how we got flight. It couldn't happen in a linear way, because if dinosaurs threw themselves off cliffs in the hope of evolving wings before they hit the ground, they probably wouldn't get a chance to breed unless they were pretty hasty on the way down, right? And of course, once you've accepted, then the thing adapts. I mean, I got tracked by an owl the other day riding my bike, and it's absolutely silent, because silences have evolved within the feathers. The other one, to illustrate it, is a cerebellum at the base of your brain evolved to manipulate fingers, yeah, or digits, so you could do fine-grained manipulation of tools and pick seeds from seed pods. It exapts in human beings to actually manage grammar in language. The huge sophistication of human language couldn't happen in a linear way. It's too big a step. It happens in a non-linear way. Something which evolved for one person exapts for another. The other fascinating one, this links back to the previous speaker, is if you don't know it, art comes before language in human evolution. We drew and we produced music before language happened. That's unique to us as a species. And that actually then continues to develop to sort of heights of modern art. Yeah, from my point of view, that's Wagner. Other people may disagree. Yeah, but if you look at modern fine art, at modern music, it's hugely sophisticated. The reason that's so valuable to us in evolutionary terms is if you move up a level of abstraction, you see novel connections. Art has been critical to human inventiveness because it disconnects us from the material and moves us into the abstract, which is why the focus on STEM education is a potential total disaster for the species, because if you don't have art, you don't have inventiveness. You're just connected in with the material. Yeah, and again, that's something schools need to pay attention to. Now, if you think this isn't relevant, the connection between these two items is significant. This is the magneto of a radar machine, and that's a chocolate bar. A Raytheon engineer in 1945 noticed that the chocolate bar melted in his pocket when he was maintaining the radar machine. This happened to lots of engineers, probably about 83% of engineers. didn't, just swore and had their trousers cleaned. He was one of the 17% who realized the significance, and we got microwave ovens. If you actually look at the history of technology, it's exaptive, not adaptive. IBM dominated the computer industry for most of the last century because they repurposed punch card machines, which they developed for controlling sewing machines in an industrial environment. That gave them first mover advantage. Apple repurposed Next. I could go on with lots of examples. This is something we teach in corporate strategy. Under conditions of uncertainty, you need to focus on exaptive innovation, not adaptive innovation. You need to rapidly repurpose something you're already good at. That's the most successful way of handling the novel. Right, so exaptation is a key concept here as well. And then we get into complexity. And in a complex adaptive system, and this is the thing people find it difficult to get. And I'm sorry about this, but one of the booths outside had the classic thing about we handle complexity by making things simple. Actually, you don't. You handle complexity by holding yourself at a complex level. If you try and make it simple, you end up missing things. Okay? Basically, a complex adaptive system is an entangled system. Everything is connected with everything else, but not all of the connections are visible or known, and they're constantly changing. Connections are a type of constraint. One of the phrases I created, which has been picked up now in the literature, is the concept of a dark constraint. That's a reference to dark energy or dark matter in cosmology. You can see the impact of stuff, but you can't see why it's happening. So a complex system is highly entangled and is inherently unknowable. So the most difficult thing for anybody from a Western background to get, it's easy to explain in China or Africa or Latin America, but it's very difficult in Northern Europe, is a complex adaptive system has no linear material causality. There is no linear relationship between cause and effect. You can't say, if I do this, it will produce this result. You can say it may do, and the plausibility is different, but you can never say this is what will actually happen. You can, however, talk about the disposition of a complex adaptive system. So you can say the current disposition of the system makes these things more likely and these things less likely. And there's a key concept I'll demonstrate to you in a minute called an adjacent possible. This comes from evolutionary biology, in which you can say shifting the system to this space will require far less energy than shifting it here. In fact, energy gradients becomes key here. We're trying to find ways of mapping the present so we can identify what is the lowest energy gradient of change, rather than say where do we want to be in the future and close the gap. And that's the single biggest difference between systems thinking and complexity thinking. In systems thinking, you define the end goal and you close the gap. You manage the uncertainty of the present by defining the future state. In complexity, you say that's a waste of time. What you actually have to do is to describe the present state and see what's possible, and then actually set a direction of travel, but not a goal. And that's a really important distinction. In a complex system, you set off on journeys with a sense of roughly where you want to go, but you don't have specific targets. We call these, by the way, vector targets when we do them empirically. Direction and speed of travel for intensity of effort, not outcome-based targets. Outcome-based targets are actually quite perverse in a complex adaptive system. Again, to give you the evidence from cognitive neuroscience, whenever people are working for explicit targets, it destroys intrinsic motivation. There is no evidence to contradict that. I'll repeat it because it's key. When people are working for extrinsic targets, it destroys intrinsic motivation. Where do we most need intrinsic motivation? Teaching, health, social services. Where do we have the highest level of explicit targets? Teaching, health, social services. So we end up building target on target on target, and I'm sure this isn't the case in Finland, but in Britain, over 20% of each hospital's budget goes on managing the measurement system with over 550 outcome-based targets. And this is called ontological inauthenticity. Those are some of your first big words for today. Basically, the measurement system is inauthentic to the system. In a complex system, you can't define outcome. Right? And I've used that sort of entanglement picture. And there's also quite a simple way of describing this, if you want a simple way of doing it, is basically if the evidence supports conflicting hypotheses and you can't resolve that conflict on an evidence base within the timescale for decision, then the problem's complex. And at that point, you don't actually try and achieve a specific plan, you move into parallel experiments around each coherent hypothesis. This is, by the way, something Agile and in particular Scrum doesn't get. They do single iterations, not parallel iterations. And that actually falls into a thing called the Hawthorne effect, if you don't know about this one. So in the 1920s, they decided to investigate productivity in a cable manufacturer in Hawthorne up in New York State. So they increased the lighting levels in the factory, people became more productive. If they were a modern management consultant or Agile book author, they would now publish a book called Light, The Secret to Productivity, and have certification schemes, with open book exams on multi-choice questions, which made you a master of the light switch, all right? Then they had some pretension to be real scientists, so they lowered the lighting level, and people became more productive. And what they found has been found in many experiments since. If you do anything novel, it will nearly always work the first time. Which is actually why pilot projects are a fundamental problem, because it's novel, you're paying attention, people respond, it works. You actually need to work in parallel. So let me give you a couple of examples of the work we're doing here. One is, I'm on a personal mission to abolish systems analysts, all right? I think they're 90% of the problem. One of the reasons is they actually listen to what the users say through the filters of their previous experience. Remember people who don't see the gorilla in the X-ray? You can't avoid that. It's just the way things are. And they're also under huge pressure to produce highly structured documents for people to code. In fact, feeling even more cynical, I think a lot of Scrum people and Kanban people are more concerned to clear the backlog than to actually produce usable systems, right? It's wonderfully satirized in Series 5 of Silicon Valley. If you haven't seen, go watch it, right? That kind of like is problematic because you need to work in parallel. So let me give you two examples of work we're doing at the moment. One is to use trios. We actually developed this initially in work in the valleys in South Wales, where we're looking at actually communities generating ideas as to things which would make a difference. And by the way, I'll talk at the end about the work we're doing on cultural change. People need to be able to feel they can do small things to make a difference before they'll listen to a bigger problem. If you give people a big problem, they get terrified by it because they can't do anything. You need to get them involved in small actions, and they'll see the bigger issue. So that's what we were doing. So there we used a concept called transgenerational pairs. So basically, a young kid could come and be taught to use a software. We use distributed ethnography here, gathering the material. Young kid could be taught to use a software, but only if they brought somebody from their grandparents' generation to work with them as a pair. And if they came up with a really good idea, they were put in a trio with somebody from the Welsh government who could make their idea work. Right? We had hundreds of those trios working over the process without the need for any significant investment. And the reason the transgenerational stuff does, by the way, which some of you will love, but you'll all love eventually, is if you want innovation, forget people between the age of 25 and 45. They don't innovate unless you put them under considerable stress, so you increase brain plasticity. Basically, by the time you hit about 2025, you lock down how you see the world based on what you need to do in the society you belong. And it doesn't really change until you reach late 40s, 50s. If you think about it in evolutionary terms, you've had a long period to learn. It's quite interesting. You don't see racism in kids before puberty. Racism comes in after puberty. Right? Because then the brain starts in this lockdown process to meet the needs of the society to which it belongs. Therefore, it will assume the prejudice of that society. Chemically triggered, actually, in 50s, the same thing happens. The brain becomes plastic again. So if you look at innovation in the humanities, it's older people. Innovation in the natural sciences, it's younger people. And the older people innovation is synthesis, younger people is originality. So that ability to synthesize things is linked to that process. In evolutionary terms, if you've survived to 45, 50 in a hunter-gatherer community, you've got something about you. You better stop leading the tribe, but you can go and teach the children. It's something I call the grandparent syndrome. Grandparents will tell grandchildren things they won't tell their children because the power dynamics is radically different. So that's been very successful in communities. Let's look at it in IT. We took 3 people together. We take a young, bright guy who can code very fast in whatever language they want. I've given up getting involved in language wars with IT people. Anything you present to them, they want to say how you did it, and whatever you did is not what they would have done, therefore it's wrong. Right? This is when I first set up an object library in the 1990s, I banned techies from access to source code because we couldn't stop them tinkering with the objects. Yeah, therefore we got no reuse. No? So basically, we take somebody very bright, very young, fast prototyper, can throw things together quickly. We couple them in a pair with somebody who thinks about the system as a whole. So that's a system architect, an end system tester, or somebody like that. And then we put them in a trio with users trained to talk to IT people. It's actually easier to train users to talk to IT people than train IT people to understand users. And we are repurposing little handbooks given to parents who've discovered their child has got Asperger's syndrome because we can actually, with a few alterations, use it intact. Nothing positive or negative about this. I'm dyslexic. So-called educational deficiencies, dyslexia is linked with innovation, or Asperger's syndrome is linked with mathematics. These are not deficiencies, they're part of this collective intelligence concept. So looking at a problem, we throw 15 or 16 trios at the problem for 3 weeks. That produces much better data for you than an analyst interviewing people with a set of prejudices. It creates material in the form of prototypes, which is still the best way to test understanding of users. Look at it, play with it, which can then go into sprints or whatever method development you want. The other one, which is a repurposing of DSDM, if anyone remembers the DSDM consortium, anybody low enough for this? Okay, this was rapid application development and joint application design. Something the Agile movement has forgotten, actually, and it's a pity because it was very valuable. Originally created by IBM Canada. We were specialists in it at the turn of the last century. You basically get users together for a whole day with a bunch of prototypers, and you throw prototypes together in a highly structured environment. Yeah? And that also included time boxes. In a time box, you guarantee a day delivery, but you vary what you deliver, or you vary the resource, but you always achieve the date. Again, that's something we kind of neglected. You don't have to have everything in 2-week sprints. And it can get crazy. I worked with Telstra for a period. They had waterfall projects. There's nothing wrong with waterfall in large infrastructure projects. And basically, nobody got promoted unless they were on the Agile team, so they invented 1-year sprints so they could say they were Agile. That's the sort of behavior you get. So what we do is we actually run a JAD session, joint application design. We produce a prototype, say in the UK. We then hand that over to a team in Mumbai without access to the original user need. That's deliberate. They get 8 hours to improve it. Then they hand it over to a team in the Valley with another 8 hours to improve it, and it comes back to the original users 24 hours later. There's a British game called Chinese Whispers. You whisper into the ear of one child who whispers to the next one, if you know that game. That's what we're doing. This is based on evolutionary biology. We're increasing the stress in the system so that we get guaranteed mutation in order to produce novelty within the system. Every time we've run that, the users have looked at the result and said, God, I would never have thought that, can I have it? Yeah, because you're actually using a complex systems technique here. You're radically increasing the entanglement in order to gain novelty. You're not allowing things to form a structured type approach. Now, I can give you more examples, but those are 2 illustrations of kind of like the way we're working, because actually reality is all about cats. I've worked this out now, right? If you own cats, you understand complexity. If you own dogs, you're trying to avoid it. Yeah, the British phrase is dogs have masters, cats have servants, right? They know we once worshipped them and they intend us to return to it at some stage in our careers, right? These are the latest additions to the Snowden household, yeah? That's Anne and Lyra. My wife has actually designed the perfect cat environment from them with designer beds in strategic locations, which has cost a fortune, but actually where they want to sleep is my traveling bag. They're actually probably on it at the moment. If I can't sneak it out before they get there in the morning, I'm not allowed to use it. Right? They find it comfortable. Right? That's how we need to think about systems. Systems with humans are often about what people find comfortable, not what we think they should find comfortable. And that involves a much more open process of discovery and an experimental evolutionary process in terms of the way we work. And by the way, this stuff is now starting to take off. This is the latest sort of map of complexity and systems thinking. And you'll actually see applied complexity is now up there. People are starting to recognize the value. And it doesn't come from systems thinking, it learns from it. But it's kind of like a separate pathway. I'll make sure you've got copies of the slides. Okay, so another key concept here, and I'm throwing a lot of biology in on this. This is a symbiote of fungus and a green plant. Symbiosis is a critical aspect of any system. Every bacteria in your stomach on which your lives now depend started off as a parasite. Now, parasites become symbiotes because everything kind of like wants to live. The best example of this, by the way, is a Portuguese man of war, if you've ever seen one, which looks like a massive jellyfish, but is actually a host of symbiotic elements, all of which actually exist independently, but actually collaborate. Now, one of the key things that people keep forgetting here, and I'm going to talk about organizations now, is the informal networks in an organization rather than the formal systems. The work I did in IBM, which was actually the first major article on Cynefin, identified that the ratio between formal and informal communities in IBM was 1 to 64. For every formal system, there were 64 informal systems. And those are only the ones who use the technology for collaboration. Yeah, IBM, and I worked for it for 7 years. I survived 7 years before I failed the test of obedience. It was 7 months in the Jesuits, but that's a different level of maturity of the two organizations, right? But the same problem in both cases. IBM survived because the informal system made it work despite itself. The key thing in IBM was to know which networks people were in, because that's how the system worked. And this is actually true of governments and large organizations. Yeah? And again, the trouble is, when you design systems based on what the formal system says it wants, rather than what the informal system will actually use. Yeah, and this requires us to rethink architecture in many ways. And the nice thing about this is the informal system is rather like these things. You can never trace it. It's like a fungus which has grown all the way around the plant roots, so you can never disentangle it. I wrote an article once called that complexity is like bramble bushes in a thicket. Yeah, everything is intertwined. You know they're separate plants, but if they're trying to break it apart, will destroy the plants. You won't get the fruit anymore. So actually starting to create architectures which allow the informal networks to pick up and use technology and start to stabilize what has utility is a lot more successful than actually trying to design the thing up front. So if we're moving into action, and this is your second cat picture, this is Lyra the first time she was allowed out and the first time she saw a bird. You can see deadly intent in that picture. She now actually leaps out of the bedroom window and catches bats in midair and lands on the grass, which I have no problem with, except she never does it when I've got the camera. And the other problem I got is she then brings them in because she thinks I don't eat properly and therefore I deposit it on the bed. All right? Either way, I want to go hunting. So, the point I want to try and make here is that if we're actually going to deal with genuine systems, yeah, then we've got to have that sort of ability to spot opportunities, to disguise ourselves, to build things forward. It's not about highly formal approaches. So within that, there are various things that we can start to do. And I'm going to show you the outputs, not the inputs. So one of the key concepts is the concept of outliers. So these are actually outlier maps. These are the results of us presenting, say, an abstract need, a business need, to 2,000 or 3,000 people who interpret that in real time without consultation. And we do this in what's called high abstraction metadata, which I haven't got time to go into now, but I'll happily do it over a drink, yeah, because we're going on for drinks after this. High abstraction metadata means the user interprets their own data, not based on text, but based on abstractions. That's actually quite an important principle, right? Because you need the abstract so you can get the combination. Again, I can go through that later if anyone wants it. We then draw the maps, and as you can see on these maps, what I've got here is a dominant view, 83%, and two minority views, probably 8%, and 9%. What I'm doing is I'm finding the people who see the thing differently. This work originally was actually worked in counter-terrorism before and after 9/11. That's where most of the investment came from. It's finding the people who've seen things that nobody else is taking significant. It's called weak signal detection. And this actually you can do in real time over large populations of people. Now, interestingly, it would be very difficult to get these people to accept this. In this one, I've got an outlier here and a dominant pattern here, but as you can see, they're connected, so that will be easier to accept. Remember I talked at the start about mapping the present? You need to map what the system is capable of doing before you decide what you do. You always start with the evolutionary potential of the present, not some idealized future. And with that, we get this modern concept on design, which is called scaffolding. Now, I haven't got time to go into this in detail. One of the big issues we had in complexity is what do we design? Because you can't design the final building. So last year, we spent a whole year working on a typology, not a taxonomy, of scaffolding types. So we have the sort of steel scaffolding, we have the bamboo scaffolding you see in Hong Kong, and increasing in flexibility as I go around this. We have nutrient lattices, which is where you put a cartilage across a burn, and it actually seeps nutrients into the skin, provides a structure around which the skin reforms. There are now medical patches which you can put on a heart, which gradually dissolve into the heart and then leave microelectrical traces where the heart needs them. And then we get this interesting thing, the kayaker, where basically it takes about 30 years to evolve the infrastructure for extreme sports. You can't just design it. Now, I'm not going to go into this in much depth, but the principle is, based on the level of uncertainty, you decide which sort of scaffolding is possible. You build that scaffolding and you design interactions around the scaffolding, and you see what patterns emerge, and once a pattern emerges and it's stable, then you add to the codification. And I'll give one illustration of this from the last major design I was involved in, and this is the largest ever failure in government computing procurement. This is a very high bar, by the way, And this is the British NHS patient record system, where they decided everybody's records should be on one centralized database. I was on the IBM bid team. I said we should no bid. I got thrown off the team. So we actually produced an alternative bid anyway, and everybody was grateful IBM didn't win this. You can't have a centralized database with massive confidential records with multiple, you all know what's going to happen here, right? It's going to go badly wrong. The doctors didn't want to change their hardware, so they put political pressure on, so hardware is now different in different surgeries. That just makes the risk go up. They put credit card controlling on the security, which is fine for a GP, but in an accident in an emergency ward, nobody's going to swap credit cards in and out while they're trying to stop somebody bleeding to death. So the most senior surgeon put the credit card in at the start and left it there all day. Reception got to hear about this, stole the medical records of a pop star, sold it to the press. You got the only thing we know for certain about a complex adaptive system, which is there will be unintended consequences. And it was a disaster. We had an alternative design. We said what you do is you computerize individual patient records onto a chip or a credit card, and you don't bother about the people who are going to die in the next 5 years because you ain't got time anyway. Keep them on paper. And then you invest in common reader technology so that any part of the medical system can read the card and write to the card so it goes with you. Then you see what patterns of use form, and those are the ones you stabilize. That would have been 50 million as opposed to a wasted set of multiple billion, but it illustrates the principle. In a complex system, you divide the core scaffolding, the infrastructure, you define the interactions, and you see what emerges before you further the code. So, to finish, a couple of cartoons. First of all, don't forget culture. Culture of users is far more important than culture of IT people. the culture determines what's possible in that organization. I say mapping culture is as important as mapping need. And the final thing to remember is that it's very easy to define how things will fail, but how things will succeed is a different matter altogether. All paths down are the same, all paths up are different. So the plea on this is understand things in a distributed way, start from the present, stop defining the future. And if anybody wants to play with some of the stuff, then we've just launched a big public database to actually capture people's stories about what they think they can do on a day-to-day basis to mitigate climate change. And that will give you some sort of experience of the sort of things I've talked about. Either way, I hope that was useful. Thank you very much for your time. We got a question. Oh, cool. I've been allowed extra time.
Hi. Based on yesterday's discussions here, like we were discussing how to make closure more popular, are we actually the most disqualified people to take the topic?
Okay, well, I was in Serbia yesterday, all right? And I will say, actually, when you realize everybody in the audience was subject to a NATO bombardment within living memory, all right, it sort of focuses you a little bit on the background of the people. Now, I actually think the sort of things you're talking about here are of high utility because they're fast development and they're based on functions. And I'm out of date on this stuff now, right? I've been C-level for the last 30, 40 years, but I was technical originally. I think what you need to do is to start to focus on what's called a co-evolutionary process between unarticulated needs and technology capability. So, for example, we will gather people's day-to-day frustrations in narrative form, high abstraction indexing. When we get a significant cluster on that, we can put a programming pair team to build a prototype. Now, I think you're in a good position to start to do that sort of work, because I think IT people need to break the manufacturing metaphor which dominates the way they think. They want people to define something which they can manufacture. You need to start to think of that as a much more fluid interaction between the two. Which, by the way, I mean, train some subject matter experts. There are too few subject matter experts in IT these days. IT has become a profession in its own right. It doesn't have the subject matter experts who can also code.